Solution of question number 3 is here for you. I'm Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. Let me thank all the viewers and subscribers for watching my videos. With your suggestions, we have been posting a video almost daily to meet your requirements. My passion of sharing has helped me come a long way now. I'm really thankful to all of you. So in this video, I'm going to share with you a complete test paper of my student. There are 7 questions in this test paper. Rational functions. It is a very important topic for pre-calculus, a part of advanced functions here in Canada. Well, in case you want to learn from me, you can always send an email on the address given. Now in this particular video, we'll discuss few questions, but share all the questions from the test paper, and these questions are from the topics like graph function and reciprocal. Very first chapter is reciprocal function, so a question related to that. Then we'll discuss domain, range and characteristics of rational functions. This is a part of each and every question. You need to figure out the domain, even if it is not asked for. Even when you're solving equations and inequalities, remember, restrictions cannot be part of your solution, correct? Now we'll talk about questions with oblique asymptote, vertical asymptote, horizontal asymptotes and holes. So we'll have a sketching problem or describing a given equation to understand, or rather test your knowledge on this topic. Then we'll have rational equations. As I said, in equations, you should always try to check your answer. There could be extraneous roots. And then we'll have an inequality. Now in this test paper, we have inequality combined with absolute value function. Now that is a challenging question, and I hope you find this question interesting and useful. Those who take up calculus, for them, this test paper, and especially this particular question, should be of importance. And then a application word problem. Always there is one, and here we have one with rate. So let's see the type of questions we have. The very first question is to sketch the graph of x squared minus 2x and its reciprocal, right? So that's the question from the test paper. Question number 2 is now sketch graph of another function. Rather, in this particular function, we have to discuss about asymptotes and holes. Well, that is part A of question number 2. Part B is another rational function where again you have to discuss the asymptotes, discontinuities. Okay. Then in question number 3, we'll have a question to discuss complete characteristics. It is quotient of linear functions, right? That is the second chapter of this particular unit. Once you do that, we'll look into question number 4, which is solving rational equations. Relatively simple equation to work with. However, it will be of prime importance for you to pause the video and solve this now. Question number 5, as I said, is of inequalities. Interesting inequality. You cannot cross multiply, you understand. Do you know why you cannot cross multiply? You have to bring all the terms to one side to solve this particular question. And then the last question, rather the second last, is a word problem, which is based on work done. And then we have the last question, which is a thinking question in this case, where we have absolute value of rational function greater than equal to 3. And of course, there is a restriction that x cannot be equal to 0. So these are the 7 questions. I'd like you to pause the video at this time, answer them one by one. Well, in case you want to learn from me, we conduct Zoom classes, right? And then you can contact me on this particular address. My students do fairly well, some of them being right on top of their class, getting the best scholarships like Akshat.
After attending university. The winner of this year's Certificate of Achievement Schulich Leader Award is anil.anilkhandelwal.
Great. Our student Akshat gets highest marks and the most prestigious Shulik Leader Award. You can be there. Join our classes and excel. Now let's talk about the solution of question number 3 from the test problems. We have already discussed solution of question number 1 and 2. Question number 1 was to sketch the reciprocal function from a quadratic function, which was kind of like this. Question number 2 had two parts, part A and B. And in first part, we discussed a simple function which had a whole, and the result was y equals to 3. And part B, we discussed oblique asymptote, which you could find by long division. Now here is question number 3 for you. The question number 3 is, for a given function y equals to 2x plus 1 over x plus 3, determine domain, intercepts, asymptotes, positive, negative intervals. Use these characteristics to sketch the graph of the function. Describe where the function is increasing or decreasing. So all these parameters you need to identify to understand this particular function, which is quotient of linear functions, right? So that is also chapter 2 for you. Perfect. So we have a detailed question on chapter 2 here, where we will discuss each and everything. Perfect. So let's begin with domain. So whenever we're talking about domain, we have to look for restrictions. Denominator cannot be 0. So we know here denominator will be 0 for x equals to minus 3. So x should not be equal to minus 3. So the domain clearly is that x belongs to real numbers. However, x is not equal to minus 3. Correct? Now they have not asked for range here, but let me add range at the bottom of this list. We'll definitely look into range. Okay. So they will have some restrictions in range also. It will really depend on horizontal asymptote. Perfect. Okay. So let's go for intercepts now. So as far as intercepts are concerned, it is easy to find the y-intercept. So first let's find the y-intercept. So that is f of 0, right? So if I substitute 0 here, I get 1 over 3. So we have y-intercept as 1 over 3, correct? So that is y-intercept. As far as the x-intercept is concerned, we have when y is 0. Y will be 0 when the numerator is 0, correct? So we have the y-intercept. Let me write down here. Y-intercept will be at 0, 1 over 3. And let's talk about the x-intercept. So x-intercept will be when the numerator is 0, that is 2x plus 1 equals to 0, and that gives you x equals to minus half. So we have an x-intercept which is at minus half 0. Clear? So we have done that. Now let me identify these things right on the screen. So we got that the restriction is a vertical asymptote at minus 3. So on this particular scale, vertical asymptote at minus 3 will be right there, correct? And the domain, all except for minus 3, the y-intercept 1 over 3. So this scale will be very, very close to 0, but positive. That's the y-intercept. The x-intercept is at minus half. So minus half will be here, right? So that becomes the x-intercept. Now let's talk about horizontal asymptote, right? So I'll discuss horizontal asymptote on a fresh page, and then all of the things as we further explore. Or we can discuss horizontal asymptote here. So let's say horizontal asymptote. So what is horizontal asymptote? Horizontal asymptote really means when x is very large, what happens to y value? It reaches a particular real number, that becomes the horizontal asymptote. Well, in a function given like this, horizontal asymptote, as we know, is the ratio of coefficients of leading terms. So here we know it is 2. But how do we prove it? That is what I am going to discuss with you now. we know from here that horizontal asymptote is, let me write down, we know it is horizontal asymptote is y equals to 2. But how do we get it, right? So that's what I'm going to discuss with you. So we have, let's say y equals to 2x plus 1 over x plus 3, right? So we can take x common. So if I take x common, I get 2 plus 1 over x divided by x common 1 plus 3 over x, correct? Now when x approaches a large value, then 3 by x or even 1 by x will approach 0, correct? So in that case, these terms will approach 0 and you're left with 2 over 1. X and x cancel. So we have a horizontal asymptote which is x equals to y equals to 1, correct? Are these steps clear to you? Right, so we got the horizontal asymptote, correct? Okay, let me do it once again on a fresh page since I know I didn't really leave much space here. So let me write down now the information which we got, and that is we have domain is x belongs to real numbers where x is not equal to minus 3, and we also calculated intercepts. So one intercept, when you put x as 0, in that case the y value is 1 over 3. So that is a y-intercept. And when you put y equals to 0, in that case the x value is minus half. So that is the x-intercept, correct? So we got both the intercepts. So once again, since we have to sketch this graph, let's sketch it as we move along. Perfect. And we got these two asymptotes, one asymptote here. The other one we calculated, horizontal asymptote, which is 2, right? Clear. Now, as far as the range is concerned, let me fill this up, range. We know y is not equal to 2, but all other real numbers. Okay, great. Now, we also identify the two intercepts, right? So, which are very close here. Okay. So, clearly from here, we can now sketch the graph. Does it make sense, right? Perfect. So, that's the graph for us. Perfect. Now from the graph, we will write down asymptotes. The vertical asymptote obviously is x equals to minus 3 and horizontal asymptote is y equals to 2. Positive and negative intervals. Now, function is positive when we are going from, so let's write down positive intervals. Positive when it is from minus infinity to left side of minus 3, correct? And then from the x-intercept, which is at minus half, to positive infinity. Do you see that? So this is when f of x is greater than 0. This is positive. Is that clear to you? Perfect. Let me rewrite. Okay, let me write down negative intervals now. Negative intervals is only in this portion from minus 3 to the x-intercept, which is at minus half. Is that clear to you? So that becomes the negative interval. You get the idea? Now comes increasing and decreasing. As you see, it is always increasing. It is never decreasing. Do you see that? It increases. But it increases from minus infinity to minus 3 and then from minus 3 to infinity. You see that? There is a discontinuity at minus 3. You should appreciate that and never include that in any of your intervals. Correct? Sketch the graph. Finally, we did sketch the graph. So that is how this rational function will look like. Is it absolutely clear to you? Perfect. And we finally also wrote the range, which will be y belongs to real numbers and y is not equal to 2. The horizontal asymptote in this particular case. Perfect. So that is how we are going to sketch the graph. So we saw that the domain of this function is going to be everything but the vertical asymptote, which is at x equals to minus 3. Range is everything but this y equals to 2 value. Asymptotes, we have those two, right? Horizontal and vertical, and it is positive in the interval from minus infinity to minus 3, and then from minus 3 to the x-intercept, which is at minus half, and is from minus half to plus infinity, but it's negative in this interval from minus 3 to half, right? So this portion is negative. From minus 3 to minus half, correct? In the rest of the portion, it is positive. And you see, it is always increasing in its domain, right? Domain does not include minus 3. So within the domain. And therefore, it's important to write increasing intervals split as shown here. Does make sense to you? That is how we have to describe and sketch the given function if it comes in a test paper. I hope all these steps are absolutely clear. Perfect. Feel free to write your comments and suggestions. In case you want to learn from me, you can always send an email on the address given. Thank you and all the best.